The moon has always stirred the human imagination, a beacon in the night sky, a symbol in stories, a canvas for dreams. From the earliest myths of the moon goddess Chang'e to the first human landing in 1969, the moon has been a place of legend and ambition. Now, more than half a century later, that ambition returns, not from Houston, but from Beijing. China, the world's rising space power, has officially unveiled its most ambitious space vehicle yet, Lunar, meaning embracing the moon. Sleek, symmetrical, and scientifically advanced, Lunar is China's first crew-rated lunar lander, a technological bridge between Earth and its closest neighbor, built to deliver astronauts to the moon and bring them home safely. This is more than a spacecraft. It is a signal. A new player is preparing to take center stage in the greatest theater of exploration known to humankind. And the question now becomes, how far will China go? In the tradition of blending science with poetry, the China Manned Space Agency, CMSA, announced two names that echo through Chinese history and mythology: Mengzhou, the dream vessel, and Lunar, embracing the moon. These are not merely code names. They are aspirations. Mengzhou will carry the astronauts, takenauts, to lunar orbit, much like Apollo's command module once did. Lunar, in turn, will deliver them to the surface, just as the Apollo lunar module once did for Armstrong and Aldrin. But these names carry distinctly Chinese cultural resonance. Lunar references ancient literature, the poetic notion of reaching for the moon, a theme deeply embedded in Chinese philosophy and song. It is a name chosen not just for its beauty, but for its inspiration. These vessels represent the fusion of modern technology and timeless cultural identity. The Lunar lander is a marvel of modern aerospace engineering. Weighing approximately 26 metric tons when fully loaded, it is comprised of two primary sections. The descent stage, equipped with autonomous landing systems, multiple engines, a navigation radar, landing legs, and a power supply. The ascent stage, containing the pressurized crew cabin, control systems, life support, and communications for the return to lunar orbit. Unlike Apollo's lunar module, which had one engine for descent and another for ascent, Lunar simplifies the architecture. It uses four identical engines for both descent and ascent. This modular redundancy ensures that if one engine fails, the other three can compensate. Each engine generates up to 7.5 kilonewtons of thrust and is fueled by storable hypergolic propellants, ensuring reliability in the vacuum and temperature extremes of space. Lunar is not just a vehicle. It is a mobile laboratory designed to support multiple days of lunar surface exploration, possibly longer in future variants. Lunar exploration demands systems that can survive radiation, extreme temperatures, and isolation from Earth's infrastructure. Autonomous hazard avoidance, allowing the craft to select and divert to safer landing sites if the programmed site is deemed risky. Its guidance, navigation, and control system, GNC, integrates LiDAR, cameras, altimeters, and inertial navigation systems. All must function flawlessly, because even a few seconds of error could end a mission. The cabin itself is designed for two takenauts, providing atmospheric pressure, temperature regulation, oxygen recycling, CO2 scrubbing, and micrometeoroid protection. There is no room for failure. In the vacuum of space, every valve, every weld, every calculation must work exactly as intended. How do you test a spacecraft meant to land on a world with 1/6 Earth's gravity? In Huailai County, China has built one of the world's most advanced lunar surface simulators. The simulated terrain includes granular regolith-like soil, artificial craters, and temperature-controlled surfaces. To simulate lunar gravity, engineers used counterweight pulley systems that partially suspend the lander, mimicking the reduced pull it would experience on the moon. It's a meticulous balance, enough weight removed to replicate physics without compromising test integrity. On August 7th, 2025, the integrated lander underwent a full-scale simulation, including descent, landing, engine shutdown, and mock ascent, all without a crew on board. Cameras, thermal sensors, and telemetry units tracked every second of the test, verifying mechanical integrity, engine precision, and autonomous navigation. This was not simply a show of capability. It was a dress rehearsal for a real mission now only years away. Lunar carries more than astronauts. It carries mobility. Attached to the side of the lander is a compact lunar rover, designed to unfold and deploy autonomously or manually once the takonauts are on the surface. This rover weighs about 200 kilograms and is capable of traveling up to 10 kilometers from the landing site. Its wheels are designed for lunar regolith, using a flexible titanium mesh architecture similar to NASA's rovers, but adapted with Chinese innovations, such as embedded terrain sensors and a differential steering system. The takonauts will use the rover to reach geological points of interest, collect rock samples, and install scientific payloads. It's a far cry from the Apollo missions, where astronauts had only a few hours of exploration time and were largely limited to walking distance. With Lunar, China aims for reach, range, and results. The full mission architecture involves multiple launches and complex orbital choreography. The entire mission could last up to 2 weeks, setting the foundation for longer future stays. Science drives every modern lunar mission. China's scientific objectives for its first crewed moon landing include collecting samples from previously unexplored regions, studying lunar geology, particularly volcanic features, installing long-duration seismometers and radiation detectors, searching for signs of water ice in permanently shadowed craters, testing in-situ resource utilization (ISRU) technologies, such as solar-powered oxygen extraction from regolith. The success of the Chang'e missions, especially the far-side sample return of Chang'e 6, has already made China the only nation to bring back material from the moon's dark hemisphere. Now, human missions like Lunar will bring greater flexibility, decision-making, and discovery potential. Lunar enters a crowded lunar landscape. NASA's Artemis program is building toward Artemis 3, a planned moon landing that may happen before 2030. India, Japan, and private companies like SpaceX and Blue Origin all have lunar goals. So, is Lunar part of a new space race? In some ways, yes. The symbolism of a national flag planted in lunar soil still carries immense weight. But China has also emphasized its openness to collaboration, particularly through the International Lunar Research Station, ILRS, a joint venture with Russia and potentially other nations. While China is excluded from the International Space Station, it has built its own, Tiangong. It has invited international researchers, offered payload space, and published its findings. Lunar may follow that same model, a national mission with international implications. In Chinese tradition, the moon is sacred. The legend of Chang'e, who drank the elixir of immortality and ascended to the moon, is told during the Mid-Autumn Festival, a celebration of family, unity, and remembrance. The moon appears in Chinese poetry and song as a symbol of longing, connection, and enlightenment. Now, with Lunar, that myth becomes science. And the dream of Chang'e finds realization in steel, solar panels, and human courage. It is deeply meaningful to a nation of over 1.4 billion people that their culture's most ancient symbol is now their most advanced destination. Lunar is just the beginning. Between 2026 and 2035, China aims to establish the International Lunar Research Station at the Moon's South Pole. China envisions a lunar logistics network, robotic cargo vehicles, communication satellites in lunar orbit, and even a potential magnetic rail launcher to send materials back to Earth orbit. The Moon will not just be a destination. It will be a platform,